Assalamu alaikum. Hello, everyone. It's a great pleasure to have you all here on our Digital Generation 2020 online camp. My name is Nadira.
And my name is Jordana. So get comfortable to take part in our online workshop in machine learning by Emad Ehsan, who is the Google developer expert by Pakistan.
Emad, how have you been?
I'm doing good. How are you?
It's a great pleasure to have you here on our event today. You had an amazing workshop last year here in Uzbekistan during Google Dev Fest. Today, we are expecting something equally interesting from you. If you're ready, then let's get started.
Yeah, thank you for having me. Last year, I had a great pleasure being in Tashkent, meeting a lot of aspiring engineers and programmers. And this time, I had a lot of fun preparing this talk. So, if you are ready to, am I ready to present?
You are definitely.
Okay, perfect. So, this talk is going to be about detecting car number plates using transfer learning and bird's eye view videos of your travels. So you do not have to record all of your travel experiences.
Yeah.
Yeah. Can you hear me? Right. Okay. Okay. Perfect. So I am also a Google developer expert for Pakistan. I have been an active open source contributor and I have been a top trending GitHub developer for that reason. I have been also involved with MIT Solve and World Bank for their identification challenge for Western Africa. I have been a judge there. So let's get to what we are going to talk about. He'll be talking about the classification problem first. Actually, in the whole purpose of doing this is to become able to train your own machine learning model on your own custom data set. So we'll be training object detection models, and for that we'll set the basis. We'll discuss the few basic concepts like what is a classification of an image, what is an object detection task, what is transfer learning, and then we'll walk through the steps of training our own model. And if you are really new to programming or even machine learning, feel free to follow along or take notes. But I hope all the steps will be easier enough for you to follow after the talk. I'll share the resources. So if enough people have joined the talk, let's visit this link, and I want to do a little survey. So if you can see this link, etc.ch/6k capital U capital A. So for all the people who are watching, please visit this link. Okay. So let's see if there are people actually taking this survey, because it's earlier in the talk, so we might not have a lot of participants at the moment. So we can probably take the survey at the end as well, but I want to have a good grasp of what the audience is. So let's see. Only one person has yet marked this. Perfect. Okay, we can probably take this at the end of the talk. So let's walk through the classification problem in computer vision and especially deep learning's application to computer vision. The classification problem is mostly the task of assigning the whole image a class, a label about what is in the image. So, for example, in the image that you can see in the slides, there's a cat. The whole image gets assigned the label cat, and this problem has been classically really difficult for computers to solve because computers do not see a cat; they actually see bits of information, the pixel and color information. So when we apply machine learning for this computer vision, this classic computer vision problem, we get pretty good results, but it still not address, it does not address the whole spectrum of problem that we might want to solve given an image. So then we come to object detection tasks. So object detection in machine learning is the task of assigning the objects in the image a certain class. So a class or label is just like assigning that object a name, their real word name, like car, a truck, a person, or a bicycle. So in object detection, in addition to assigning the object a name, we also try to find the bounding boxes that surround the object, because that's how we build on this. Building on this, we move to the part of instance segmentation, where we detect exactly where pixel-wise an object lies within an image. So this picture gives a good summary of what uh, what is classification of an image. So in the leftmost photo, you can see the whole image is classified as a cat, but the task of classification plus localization is finding where the cat is. So getting an estimated box around where the cat lies in the image, or an object for that matter. And the task of object detection is detecting multiple objects and localizing them as well. So object detection not only classifies specific objects, which class or what is the name of the object, as well as finding their bounding boxes. And instance segmentation is the task of pixel-wise assigning each pixel a value or a class, to which class does this object belong. So for this example, uh, here it's pretty clear that the task of multiple objects lies under the domain of object detection and instance segmentation, where there are multiple multiple objects of same category within the same image. For example, in the third image, there are multiple cats within the same image. We call them instances of an object. So this vocabulary might be a little bit handy when you want to train your own model or try to read a white paper on deep learning, because you might be familiar with instances and objects in object-oriented programming, but in deep learning they are a little bit different. And today we'll be working with transfer learning. Transfer learning is a technique of taking an already trained model and retraining it. So what are the benefits of actually transfer learning? So let's first look at how transfer learning works. You take the model that you had trained using your data set, and it was predicting, let's say it was able to predict animals. So let's say it's an object detection model that you feed an image and it tells you where in the image lies the animals, and it also classifies those images as cats, dogs, also gives the bounding boxes. So if we were to use the same model for object detection of another data set, we'll reuse the same model. The inner model architecture would remain the same. The only two differences would be the data set that we feed. So let's say in this example, we are training our model to detect car number plates. So data set is going to be different, and the number of classes and the class names are also going to be different. So previously we were detecting cats and dogs. Now we'll be detecting number plates. So transfer learning, training a model using transfer learning technique is a lot faster because you are actually retraining it. You are not training it from scratch, and it also converges faster, gives good results on predictions because of this reusability. So we'll now walk through the steps of training our own models. We'll use Google's Colab, which is a free resource available. If you do not have a GPU to train your machine learning or deep learning models, you can use Google's Colab, which is a free service available and which we'll be using here. I have put the link of my Colab that I used for the demo of this talk, and it is available at bit.ly/car-numbers-play. And let's play with some things. So here I am on Google Scholar. Let me zoom in a little bit. So Google Scholar works with Jupyter Notebooks. If you are familiar with Jupyter Notebooks, here you create a simple cell and you can run any command. A command that starts with a an exclamation mark is a Linux system command, and a command that starts with some code, Python code. It is actually, it holds the Python code and you can run it from as if you are running from it from the command line. So let's test if our notebook is really connected. So let's import this class and download some image from the internet and save it as test0.jpg. And let's see if we have, okay. So the notebook is connected and working pretty fine. Now let's download. So in this, for this talk, I've used vehicle number plate detection dataset that is provided on Kaggle. Its link is available here. And here you can see they have provided the file Indian number plates.json. Click on it and let's see. Oh, we probably need to click download. So we are going to download it to our system, and Colab is pretty easy to use. You can actually use it like a file system as well. So here we are going to click upload, and we are going to select the file that we uploaded. So it is here. Our file has been uploaded. This is the file explorer on Google's Colab, where you can explore the current files in your current directory. You can go inside a directory and see the files within it. So here is our file, and let's see if our file is available in our current directory. Here we can see it is available with the name that we want. So let's unzip it with Linux unzip command. And By the way, these outputs that you might already be seeing are from my previous runs. So here we have unzipped that zip file, and we have a file Indian number place.json. And let's import a few libraries. These are Python libraries that we'll be using for processing the data. So if you go to the datasets page, you might see that the format, this is the format in which the professor of who uploaded this dataset has provided the image file. So they have provided us with a JSON file in which there are multiple entries, and each entry has a URL from where we can download the image, and also the annotations about what is in the image. So we are interested in detecting number plates in the image, and also we have the details about image height and where exactly in the image lies the bounding boxes. So these are the coordinates of the bounding boxes. So using that information, we know how to pass this JSON file. So we are going to load it to a pandas object. Pandas is a Python library. Is my screen visible? Okay, so I think there was a connection issue. Can you see now? Okay, perfect. So, okay. So we are going to load our pandas object and see what is, okay. So we haven't imported the pandas library. Let's run this cell first. By the way, to the moderators, if you are following along and not understanding something, you can ask from me as well, because the viewers might also have the same questions. So feel free to ask any question in between. So we have imported the JSON file. We ran df.head, and it gives us the top 5 entries that are within that JSON file. So we have content that contains the URL of the image, where to download it, and there are other label informations that we saw in the JSON format. And we are going to create a Linux directory using Python command. We'll name it number plates. Let's see if our directory has been created. Here we see we have a directory number plates, and we are going to set a Python variable named dataset folder, where we use, which contains the absolute path of that directory. Now we are going to do some pre-processing on the image, and I didn't write this code. I actually took it from a notebook on Kaggle. So you can see it on this URL if you want to see it, but I'll explain how it's working. We are creating a Python dictionary, and within it we are setting the image name, image width, height, top x, top xy, bottom xy, the information about the bounding box that we want to create. And we are just initializing them as lists. And here we are reading through all the entries in the JSON file that we loaded in the variable dr. So it goes through this loop goes through every row in that JSON file. It reads the content variable that we just saw. That this content variable has the URL to the image in AWS Cloud, from where we are going to download this image. So it reads that URL, and using URL lib, it is going to download that image, and we are going to save that image to our dataset folder in this format. So it will be named as image underscore n counter. So image underscore one.jpg and so on. And we are going to, here we are, the variable, the data holders that we created above, image width, image height, and bounding box information, we are going to save each image information in that data holder. We'll use that later for defining the bounding boxes. And let's run it. So it is going to download all the images one by one and save them to our dataset directory, as well as save the bounding box information in our dataset variable. So there are, I think, 237 images, so it should not take a long. Okay. And while that's running, let's see what are we doing here. So the dataset variable that we created above, it was a dictionary, a simple object of Python. And now we are converting that to a data frame and object data type that is available to us through pandas. So we are converting a dictionary to pandas data frame, and we are going to see what is in that data frame. Actually, pandas is a very useful library if you are dealing with a lot of numbers or huge data sets that you want to sort. It has a lot of great visual functions as well. It shows the image and table. So here we have 37 car images have been downloaded, and let's run this cell now. Okay. By the way, to check whether our images were downloaded or not, we can click here on this folder icon, and we have in our number plates directory, we downloaded those images, and let's see if there are. Here we can see there are about 237 images downloaded in JPEG format. And let's see what's inside each image. So here we can see a car, and the car has a number plate here, which we are going to detect, and the corresponding dataset variable that we had created, it has the information about the bounding box. So as far as this notebook is alive and running, we have that variable in the memory. So here is another car with number plate here. Okay, so to the next step. Now let's use our variable that this now the bounding box information is in df variable, and we are going to see a few random images and see whether the bounding box information is correct or not. So the show image function is using CV2, which is a computer vision library for Python. It is, so we are providing it with an index for an image. Let's say we want to see 50th image, and it will use that index and combine it with the image name. So image underscore 50, then any image with that name will be displayed. And here we are using the bounding box information and using matplotlib library, we are going to draw that bounding box on the image. So I hope you can see this. Let me see if we can zoom in. So here we have a car, and here, if you can see around the number plate, it has drawn the bounding box. So this is the bounding box information that we have in df variable. Let's see some other bounding box, some other image. So this image does not contain a car. It only contains a number plate, and it has two number plates actually, and only one has a bounding box. Probably, it could be that it might have two bounding boxes, but I might be reading only one. We might need to work on that, but this would work as well. So let's see 10th image, and we have a car around which we have bounding box. So now we are going to talk a little bit about what deep learning framework are we going to use.
Emad,
So,
sorry
yep.
for interrupting you. At this point,
Yeah,
one
sure.
question arises. How do you handle a missing or a corrupted data in a data set?
Yeah, that's a really good. We imported a bunch of libraries at the top. Here we have pandas, numpy, and cv2, and these are a few machine learning and computer vision libraries that are really useful for refining dataset and filtering out what is, if there are missed classes in the image or not. So this specific dataset is a really small dataset, so I was able to verify just by looking at it. But if you want to verify whether there are some empty rows in the image using this pandas object, bf is a pandas object, we can check where in the image those empty or missing information is. So there are some handy functions like is null and of that sort. You can manipulate the data with a few functions. We can see where we have a bunch of functions to sort the data set, to see where there is malfunction information, and we can probably filter that information out, remove that from the training, because that would not contribute to our training. Was that helpful? Okay. So for this object detection task, we are going to be using YOLO framework of object detection. There are a couple of really famous object detection frameworks, and so the two mainstream frameworks for object detection that gained a lot of popularity in the past years were Mask RCNN, and which started from a paper from Facebook AI Research, and another one was YOLO. The Mask RCNN is comparatively slow, and because it does a lot of things, it does instant segmentation, assigning each pixel an object, and this is a very compute intensive task. But YOLO also does a compute intensive task with is object detection, but it does it even better than Mask RCNN because it uses a novel technique of there are a few technical things like non-max suppression and intersection over union. You don't need to worry about that at the moment, but that makes YOLO framework really innovative. And we'll be using YOLO.NET by Alexebi, and so they have provided the whole code of how to train the model, and all the instructions that we are going to be following, most of them come from this project. So let's get back to here. So to transform our data, in order to train the darknet model on our data set, we have to transform our data set into a format that YOLO recognizes. And so for YOLO, there's a requirement that each image must be specified must have a name. And so here, like, we have assigned each image a name, and using the same name, we are going to create a file in the same directory, which will contain the bounding box information of this image. So that file will contain this information. So here we have an ID of the object that we are going to detect. So in our case, it's only one object, which is number plates. We are only interested in detecting number plates. So it will be detecting only one object. So we will use 0, we'll followed by space, and the coordinates of the bounding boxes. So top left x, top x, top y, and bottom x, bottom y, all separated with spaces. But one thing to note here, that these are not absolute values. These are the x, y coordinate values divided by the width and height of the image. So that's why you see these floating values instead of integer coordinate values. So we are going to convert our data set into exactly this format. So the data frame had the bounding box information, and it's a lot hot here in Pakistan. So here, let's see what's happening. So we have 237 cars. We read the bounding box information of each car, and we convert them. We divide them. We divide the x coordinates by width, and the y. Sorry. So actually, let me tell you something. These are not x, y coordinates. These are the coordinates of the center of the bounding box. So this bounding box that we see around the cat, it has a center. So YOLO wants us to provide the coordinates of the center of the bounding box, and the width and the height of that bounding box. And these are relative widths and heights. So width is divided by total width of the image, height is divided by the total height of the image. So here we are doing that. We are calculating the width of the rectangle, height of that bounding box, that rectangle, and the center of the x coordinate of that rectangle, y coordinate of center of that rectangle, and we are saving that information. Each image for each image, we are saving that image information with the same name, and but it ends with .txt extension. So let's run this cell and let's see what happens. Okay, we have an error. Bottom x. Let's see. We probably let me see. We probably ran that while explaining about data set refining. I ran another command that probably rewrote df variable. So let's run this one time, and here we have. Let's run it again, and this time we can see that. So it has printed all the information that it has saved, and let's see if it has created those files. Okay, so let's refresh it. Okay, so corresponding to each image, we have a .txt file which contains the information about the rectangle, the bounding box rectangle's center coordinates and its width, relative width and height. So now that our data set is ready to be fed to our YOLO.NET model, let's move on to the next step. Okay, so here, as precaution, I'm checking whether my conversion was right or not, because we have now converted the coordinates that the dataset provided, those integer coordinates, to double values, float values. So here we are converting them back to absolute values and drawing them on the car just to check whether our conversion was correct. So it draws the bounding box at the correct place. So it seems all right. So let's move to the step where we are going to be using darknet. Okay, so now uh, I told you the background about YOLO darknet, which so YOLO is actually the framework, the paper, the name of the paper that came out in I think 2016 about how to do object detection really fast. And darknet is the name of the GitHub project. It's, you can say, it's implementation in code that you can use, or you can also use, which we'll be using here. I am using version 4 of YOLO by LXB, and let's clone it here. So as I told you, any command starting with exclamation mark is a Linux command. Let's clone it, and if we have all the files, let's compile our project. Seems to be compiling fine. Okay. So let's configure. It is going to take a little bit of time, but let me show you a few things that we need to do. So for YOLO v4, we need to specify a few configuration values. So since we have cloned our model, our repository, which is available to us here, we'll need to be using, okay, so here we can find a configuration file that is specified in these instructions, and we can update them. But since I think this demo can take a lot of time because Colab is not really fast because it's running in the cloud, uh, I should probably walk you through the steps. So we are going to make a copy of this configuration file in the darknet directory, and we are going to update a few values. So about subdivision, this is set this its value to 16, max batches 2000. So deep learning on GPUs usually processes images in batches, and here we are using it, and those batches are passed through the model multiple times so as to refine the hyperparameters and get good accuracy. So these are configuration values related to those. And here we are specifying that we only want to detect one class. Then we'll create a file obj.names, and we'll set the name of the classes that we want to detect. In our case, the only class is number plate. We also need to create a class with in at this place obj.data, and we need to put the absolute URLs of the files. So here we have train.txt, that is important, obj.names that we created above, and backup directory where our train model would be saved. And so let me show you. Here we are creating that train.txt file. Train.txt file is a simple file that will contain just the URLs of all the images in the number place directory that we just saw. And here we are down. So for transfer learning, I told you that we use existing weights. So we use an existing already trained model, we retrain it on our custom data set, and we use it for predictions. So here we are using the data the YOLO pre-trained model that we are going to use for this The model that I am using here is called YOLO Tiny. Actually, it is a very light model that is only about 19 MBs in size, which plays to our benefit because we want to deploy this model. We might want to deploy it in a mobile app for offline detection, or in a web app where we have a lot of resource constraints. So that's why we are using YOLO Tiny. It has lesser accuracy compared to other YOLO models, but those models are more than 200 MBs in size. So here I have written code. So you can walk through all the steps, and you can also save your model to Google Drive. So instead of going through those steps, I've explained those, but for the demo, I will show you how to use this model. So I'm going to attach my Google Drive to my Colab so that I could copy or copy files from here or from there to here. And I am going to use my email, allow it access to Colab, and it will provide me with a token that I will paste here. And now my Google Drive will be mounted as a file. So here we can see that we have G Drive, which contains all the files from my Google Drive. And so here is, I have authenticated with my Google Drive because after the training, I want to save my model to Google Drive, because after some minutes of inactivity at Google Colab, all of your progress gets lost. Here's the step of training your model. You give darknet the command to train, you provide with the file URLs, and it trains. So you can follow this. What I'm going to do is I am going to load my weights from Google Drive. I have already authenticated. I am going to copy my train weights from this directory to here. Let's see if that works. Okay. So we have tinycar.weights. This is the model that I trained using the same code in this Colab when I was preparing for this talk, and let's use it for inferences. So I have already written a few internet images, URL of a few images that I'm going to download for demo. So let's test the first image, download first image and save it as test1.jpg. Let's see, where is it? Here it is, test1. This is the car that we want to detect the number plate for. And here, let's run the test command on darknet and give it the name of the file. We want to detect test1.jpg. So we have an error. Let's see, what is it? So, okay. So actually, I skipped through the steps of making those configuration files because that is a lengthy process that I explained here. Turns out for the demo, I still need to create these 3-4 files, but how about I show you a few files that I had already run predictions on. So I have downloaded those files already, and I trained the prediction on them. So here's the first image. This is the prediction that I ran yesterday, I think. So it labels the number plate, and it also gives the confidence score. So for first image, it is 100% confident that it is a number plate. For the second number plate, it is about 90% confident. And for this number plate, it is only 54% confident. So actually, since we used YOLO Tiny, which is a really small model, That's why our accuracy score is really low, but it's still the benefit that we have of using a tiny model is that we can deploy it on small devices. This is another image that I used as a test, and for this, it gave an accuracy of 90%. Here's a really tricky image. It has watermarks, and it is an image of a bike. In our training data set, we did not have any images of motorbikes. We only had cars, but our model is successfully detecting number plates on other types of vehicles as well. Here's a vehicle, and these are the demos. I highly recommend that you go through this notebook. I have provided the link in the presentation, and you run it through. You run it yourself and run the inferences and see how it works. So, and the last things that I would like you to do is, once you have extracted the number plates, the bounding boxes along your number plates, you can extract that image and you can turn it into a mobile app. Another innovative thing you can do to impress your class fellows or your colleagues is you can connect that with Google Vision API, and you can feed that number plate to Google Vision API, and it will give you exact text that appears in that number plate. So LED 224, what is the exact number within that image? Here we were only detecting the object. The other task is actually understanding, which lies in OCR, object character recognition domain. Another thing that I would like you to do is there are a few really cool data sets provided on Kaggle. So as an exercise, you can use this fruits data set and download this data set. It is really plain and easy. Here they have provided the images. This is an image, and they have provided XML files. So just like in this demo, I passed a JSON file, you can pass this XML file to extract the object bounding box information, and you can use that to train your YOLO model. Another really cool data set is from Stanford AI Lab, and it is a car data set. It is a really huge data set, and I think it will take about half a day of training. So, by the way, for my 237 images that are trained, it took me about 3.5 hours on Google Scholar. So, but it's free, so you do not have to worry about the resources. So this is a really cool data set provided by Stanford that you can use to detect what type of car it is, what model it is. It is a really fun one if you are into cars. And if you successfully complete any of these tasks, do not forget to tweet to me or direct message me on Twitter. So I'd be happy to learn about your progress. And the code for this project is available on GitHub at Emad Ehsan/tfjs-ampr. So it is actually what I showed you today is actually first part of using automatic number plate recognition on the web. So in the second part, what I'm going to do in the next few weeks, I will convert this model to work with TensorFlow, and then I'll convert it to work with TensorFlow.js on the web. So if you want to follow that progress, you can probably follow this project here as well. So I think with that, that's all from me. If you want to connect, feel free to connect with me on LinkedIn, GitHub, or Twitter. So over to you. Hello, Navira.
Hello.
Durdona.
Can you hear me?
Okay. Yep, I can hear you. Do we have any questions from the viewers?
Yes, here we have some questions for you. You might have to repeat some information you mentioned earlier. The first
Okay.
question is, are there any limitations of this implementation? Now we're
Yep, there
talking
are.
about the algorithm used.
Yes. So actually, we use a tiny model for object detection. We use the tiny version of YOLO. It is a really small model, and the plus side of it is it is really fast. We can use it on any small device. But the negative side, the limitation is that it does not always give perfect results. So for the 5 or 6 images that I showed you that I tested on, they all had this. They were predicted correctly, but if you look at the training metrics, it seems that this will not be able to detect all types of number plates. So if you want to have good accuracy, probably go with training a large YOLO model. So usually machine learning and deep learning is classified into 3 types in terms of how we train our models. So there is supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, where we tell the model what what to look for, we train it on some data, and then we test it on some unseen data. That's what we did here. So we trained it on a few number plates data set, and we tested it on some images that it had not seen. In unsupervised learning, you train it without any already given uh, data. So you do not tell it how to how to map. The algorithm figures that out. And for reinforcement learning, we place a mechanism of reward and feedback, reward and punishment, where we reward the algorithm. So algorithm has no idea about what's happening. It starts from scratch. We reward it if it corrects a number plate, for example, correctly. We give it points in positive. If it does not uh, detect a number plate, we reward it negatively. So, yep, those are the main types.
I see. What are the stages of building a model in machine learning?
That's a great question. In fact, I skipped through a few steps because we wanted to use transfer learning. So we just created a few basics and jumped to transfer learning. But usually in machine learning, we have the process of so scientists usually classify it in 7 steps, but I see it as 3 steps. So you have your first step of collecting data and refining it. The second step is training the model and refining the model. And the third step is deploying the model in real world and doing predictions. So those would be the main steps for a beginner.
Okay, considering long list of machine learning algorithms, how did you decide that you're going to use the algorithm you mentioned during the
Yeah,
implementation?
exactly. So for this task, like we had to choose from what do we want to achieve. Here we were interested in only finding out where in the image a number plate lies. So that would fall under the category of object detection. We are only interested in locating number plates, even if they are multiple. So, and for object, first we classify to which domain of deep learning does this problem belong. Then we look for what are the good frameworks that solve this problem really efficiently. So for object detection, the 2 frameworks that do this really good are Mask RCN and YOLO. but YOLO is really fast, Mask RCN is a little bit slow, and I want this project to extend I want to extend this project for the web as well. So I wanted my model to be fast and tiny. So that's why I went with YOLO. If you do not have constraints with the resources, but you want perfect results, you might want to go with Mask RCN.
So, Emad, so there are a lot of live questions that we're getting, but I need to mention that everybody thinks that you work at Google. So I think I need to clarify this moment for them, because Google
Okay.
Developer Expert doesn't necessarily mean that you work at the Google. So it means that you are considered as an expert by Google. So you can work wherever you want to, but it doesn't mean you can't be a Google Developer Expert. So he's a Google Developer Expert. So considering that, I'm going to reshape some questions. So the last question that I got was, can younger people like 14, 15 age work at Google? Or let's reshape this as Google Developer Expert. Can they become a Google Developer Expert at this young age?
That is a really good question. Actually, I am since I'm a Google developer expert, it really means that I am an expert from the industry that is recognized by Google for certain skills. So Google has a lot of other programs as well. As a school student, you cannot become an employee of Google, but what you can do is participate in the programs that Google has. So for school, I do not remember the name. Probably its name is Code In by Google. So it is for high school students that want to be a part of something, some innovative projects that Google is doing. Google rewards you with probably a prize if you successfully complete their workshops. And then they have, for university students, they have this program that's called DSC. So it's Developer Student Club Leads. So DSC leads. So you can become a DSC lead for your university. You will work with a lot of Googlers. You will still not be an employee of Google, but you will get to travel to a lot of places, hold and organize events at university. It will be a really fun experience. And after you graduate from university, then you can definitely join Google. And if you have participated in those previous programs, that would be really good on your resume. And if you choose not to join Google, you can still work on your own ideas, projects, or work for some other company that you like, and you can still become a Google developer expert like I am.
So here it is, viewers. So you can become a Google Developer Expert, but at a certain age, so this is a little earlier for you, but you can start from something else, becoming a DC leader, as I got it from him at your university or school, whatever you are studying at. So another question that I'm getting is, what do you think, like colleges, MIT, Yale, will accept students with background in software development and machine learning? This is, but I can answer this question too. Yes, of course. It doesn't have to be asked from a Google developer expert to answer this question.
Yep.
And another question for you, Emad. He is writing that, Emad Ehsan, I have a question for you. I am 8 years old and I know HTML, CSS, and some Bootstrap and JavaScript. What advice would you give me? How
this
to
is
become
probably
that's the spirit actually.
Yes.
So I would say that do what you love and keep exploring, learn new things, build something cool, and keep exploring. Do not stick to one thing. If you explore the web, probably make mobile apps, probably do machine learning, probably learn public speaking. I would say keep learning. So keep learning and keep improving, keep moving forward. Do not give up and do not stick to one field.
Sure.
And for the person that asked about MIT and Stanford, yes, I would suggest that be really specific and try to make some some extraordinary effort in the projects that you work on and in your study if you want to get into MIT or Stanford, because they are looking for extraordinary people who stand out. So better work hard and work smart.
Completely agree with you. And the last question, I hope. So this is from another sweet guy, I think. So he's calling you teacher. So teacher, can you teach about face detection? It's so sweet.
Yeah, so actually, that is a pretty good question. In fact, what you can do is you can go to kaggle.com, KAGGLE.com, and you can search for face detection. And you will find a lot of notebooks and data sets. So let's say we want to directly go to some data sets. Here we have been provided, let's explore this data set. So here you can find the information about where those images are, and you can probably see this data set has exactly the same format that we use for car number plate detection. So you can probably start using this model for your face detection model right away, and you can probably train your face detection model. You can probably see this photo. Here they are detecting the faces. If you want to recognize the person, you will need some personally identifiable, probably private information as well. So, but here you can detect faces, and you can use the same code that I provided in the notebook. So if you do complete this, do reach me out, and I'll be happy to know your progress.
So remember how to reach him out in the Twitter or GitHub, Emad Ehsan.
Or on LinkedIn too.
Yep, you can find him there. So that was the end of our session. It was very nice. Thank you for your time, Emad. As usual, it was a very informative session. You know, we had a session with you last year, so I do remember that. So the knowledge you shared and your personal experience that we are introduced to, I think is very crucial for young generation, because they are seeking for the coordination, direction, and I think the sessions like this are exactly the things they are looking for. So hope to see you again. It was great. Thank you.
Thank you.
Thank you for having me. Thank you.
So, dear attendees, before we have Emad in our session, let's recap what we had today. Today we had a workshop session by Emad Ehsan on machine learning topic car number plate detection. During the session, you were introduced to classification and object detection problem, transfer learning, and also training a model in your own dataset. Also, you had an opportunity to play with a demo. So this was the quick recap of our today's workshop session. Also, during the session, you received interesting answers to your sweet and interesting questions by our speaker.
And we're gonna leave the links to the presentation or the demo, everything on the description of this video, so you can find it there.
And we believe that you enjoyed the session.
Yep.
See you soon.
Next time.